Hello everyone. Our lesson today is determining the types of roots of a quadratic equation. Remember how to factorize x power 2 minus 8x plus 15 equals 0. First, open two brackets. The square root of x power 2, it will be x. Two numbers, their product is 15 and their sum equals negative 8. The numbers are 5 and 3. The sign positive, so we take negative and negative like the middle. We get x equals 5 or x equals 3. The second one, x power 2 minus 4x plus 4 equals 0. The same, open two brackets. X, two numbers, their product is 4, 2 times 2, and the sign like the middle. So we get x equals 2 or also x equals 2. Finally, x power 2 plus 9. X power 2 equals, move plus 9 in the other side by negative 9. X equals positive or negative, the square root of negative 9. We studied before, x equal positive or negative 3i. So x equals 3i or negative 3i. Okay, look at the two roots of the first equation, 5 and 3. So the two roots here are different. We have two different real roots. Okay, look at the second, x equals 2 and x equals 2. So we have two equal real roots. The third, 3i and negative 3i. So we have two complex and non-real roots. Okay, how to know the type of roots without solving the equation, without factorize the equation? First, remember the general formula to get the root of the quadratic equation. We have the general formula, x equals negative b plus positive or negative square root b power 2 minus 4ac over 2a. We have the discriminant, it's under the square root. So b power 2 minus 4ac, we called it the discriminant. Okay, first get the discriminant of the equation. If the discriminant equals positive or greater than 0, we have two different roots. Okay, if the discriminant equals 0, we have two equals root. If the discriminant is negative or less than 0, we have two complex roots. Again, first get the discriminant. If we have positive greater than 0, like 5 and 3, the first example, we have two different real roots. If we have equal, like x equal to and x equal to, we have two equal root. If we have negative less than 0, we have a complex real and non-real roots. For example, determine the type of two roots of the following equation. We said before, without solving the equation. First, get the discriminant. b power 2 minus 4ac. Coefficient of x power 2 equals a, so a equals 1. Coefficient of x, it will be b, b equals negative 3. And absolute term c equals 5. By substitution, b power 2 negative 3 power 2 minus 4 times a times c minus 4 times 1 times c 5 equals 9 minus 20. It will be negative 11. Negative 11, it's a negative quantity. So the two roots are complex and non-real. Why? Because the result of the discriminant equals 0. We said before, if the result equals negative. If the result equals negative or less than 0, it would be two complex roots. Okay. We have another example. Find the value of k, which makes the two roots of the equation x power 2 plus 4x plus k equals 0 are equal. Okay. First, since the equation has two equal real roots, which means the discriminant equals 0. We said before, if we have two equal root, the discriminant equals 0. Therefore, equals 0. We get b power 2 minus 4ac equals 0. Put a and b and c. A, coefficient of x power 2, 1. B equals 4. C equals k. By substitution, therefore, 4 power 2 minus 4 times 1 times k equals 0. We get 16 minus 4k equals 0. Put 4k in the other side, so 4k equals 16 divided by 4, then k equals 16 divided 4, k equals 4. Then the value of k equals 4. Another example. Find the value of k, which makes the two roots are complex of the equation. Two roots are complex, then the discriminant less than 0. Since the equation has two complex roots, then the discriminant less than 0, which is b power 2 minus 4ac less than 0. A equals k. B equals negative 8. C equals 16. By substitution, therefore, negative 8 power 2 minus 4 times k times 16 less than 0. 8 power 2, it would be 64. Negative 4 times 16, it would be negative 64k less than 0. Okay, put 64 in the other side. Negative 64k less than 0, less than negative 64. 64 moved in the other side by opposite sign, it will be negative 64. Divided by negative 64. We studied before, when we divide in the inequality by negative, we change the sign. So k greater than negative 64 over negative 64. We get k greater than 1. The values of k greater than 1. So we take k belongs to the interval, open interval, 1 and infinity. Thank you.